Hi there, this is Architect David. Welcome to Arkida, where you can learn anything and everything about construction. For this video, we will be discussing about how a floor framing is done using steel. Before we will start, let me just share with you a short video of how concrete construction is done, because from there we will put in our steel decking. So from the site, you will have to level it off. Then you dig in your foundation works or your foundation pits. Put in your sand base or gravel base. Place in your formworks and your rebars. Now pour the concrete. When it dries up, you start covering your columns. Meaning to say, you will increase now your rebars to the actual height of it. Then you start covering your rebars. Then you start pouring concrete in it. So the concrete, you will have to wait for it to dry for around 14 days before you take off the formworks. Then you place in now your scaffolding framing down below, and you start putting in now your formworks for your second floor concrete pouring. Put in your rebars, then pour the concrete. So it's the same as what you did on the ground floor. You will now extend your columns. You cover it up with your forms. You pour the concrete. After another 14 days, you place in your scaffolding and your formworks and your rebars for the next floor above. This video will now show you how a steel framing is done. Obviously, you will have now your concrete pedestals. This is one variation of how to come out with your steel posting. Place in your brackets or angle bar frames. Bolt it in. Then rivet it to your column. Now you have your beams. Again, this is just a particular way of what type of beam to use. This is one installation of how to strengthen or how to connect your beam to your column using gusset plates. Now this is again an angle bar wherein it is riveted to both the beams and the columns. So you have a C channel. Again, you will place in your supports, your brackets, and rivet it in. So now you have now enclosed your upper floor. Obviously, you will have to place your brackets on each and every beam to the actual floor joist. Then you will place in your connectors, or if you would like to call it, in the wood variation, it's called blocking. That is to maintain the rigidity of your floor joist. Since this video shows a cantilevered beam, it will now show how the column is installed on the outside portion of the cantilever. This one is a variation showing stairs. Using steel framing, you will just anchor it to the beam above. Then you start installing your tread and risers. Now this is what a steel decking looks like. So it comes with several variations, with a simple looking like a GI sheet to one that has grooves in it. Meaning to say, you will install that into this beam, you will rivet it, then you will pour concrete on top of it. Obviously, you will still have your wire mesh as some sort of your support for the cement itself. Again, another variation of the different types of steel decking. Now let me introduce to you a video done by a company called Comfloor. They specialize in various types of steel decking.
Comfloor is a composite steel floor decking, ideally suited to modern high-rise structures. Available in both shallow and deep decks, the Comfloor range represents some of the most economical floor solutions and is arguably the most efficient choice of profile currently available anywhere in the world.
The composite floor is one in which the steel deck mechanically bonds with the concrete topping, so that the steel and the concrete work together to form the floor structure. The technology reached the UK at a time when the concrete had a dominant three-quarter of the market for multi-story building. The introduction of steel profile using composite slab technology changed the market forever, and today 70% of multi-story building are steel frame. The principal benefits of building with composite steel flooring system are increased speed of construction. The deck instantly acts as working platform, construction stage bracing, providing diaphragm action to the floor, reduction in the weight of the floor, overall building height reductions, inherent fire safety property, and the simplicity of attaching building services. Circular embossment in particular reduces the amount of distortion created during the rolling of the deck. This later leads to reducing residual stresses within the profile, which help the flatness of the deck. The embossment along with the round edges increases shear bond action between the deck and the concrete slab, and has led to increase in the MK value found from the test that was carried out here at Imperial College. As with any construction product, this decking are tested to European standards. Eurocode 3 for cold form steel and Eurocode 4 for composite slab and beams.
The Comfloor 80 and the Comfloor 60 profiles were designed to span further in the unpropped condition over any other profiles in the world. Having a profile that spans further is only half the story though, because in floor areas where the spans are not so important, it means the gauge thickness can be reduced. Smaller gauge thicknesses means that the overall floor cost can be dramatically reduced. Deck design is not an exact science. However,
one of the key areas for the design of these profiles is to try and ensure that the cross-section of the profile is fully effective.
The introduction of the large corner radii is to reduce the individual element lengths of the compression zone of the profile. The CF60 and the CF80 are circular embossments. The purpose of these circular embossments is to ensure that the concrete works with the decking.
They put less stress into the profile, which actually means that there's no twisting of the profile. So when it's laid in situ, the decking actually sits firmly onto the top flange of the beam.
When you look at the cross-section of these new profiles, you'll notice that the bottom stiffeners in the trough have actually been pushed apart, as opposed to a traditional central stiffener. By doing this, the shear stud connector can be placed centrally within the trough,
and this means that the stud will achieve its full capacity.
Comfloor decking will span further than any other flooring deck profile. In the double span condition, Comfloor can span in the region of 4.5 to 5 metres without the need to prop. In a typical grid structure, traditional composite decks require a greater frequency of beams. The use of Comfloor can reduce the number of components by as much as 25%. Let's consider a typical crest configuration with a central stiffener. As the horizontal elements will at some point be in compression, it is important to keep the individual B/T ratios for these elements to a minimum. The location of the shear stud connector within the deck profile is of paramount importance. The latest Comfloor profiles only allow the studs to be centrally placed, which is the optimum position for developing the stud capacity. Extensive testing and fire engineering work have resulted in fire ratings of up to 4 hours when using a light mesh within the composite slab and no protection to the deck.
We are proud that we have a very high quality controlled manufacturing process. At the beginning of each order, then at regular intervals, quality checks are carried out on the Comfloor. Only once these checks are satisfied will production continue. Comfloor has gained great favour since the launch of Comfloor 80 in 2004, with hundreds of thousands of square metres supplied all over the globe, and demand only growing. The world realises the great benefits of the Comfloor composite floor system.
Essentially, it starts when we got our steel frame erected, and obviously we hang safety netting beneath the floor where we want to be working. The steel composite panels actually come in bundles on the back of a flatbed and lifted onto site by crane, and typically then we take from these bundles of say 15 sheets, they're actually placed in position and then fixed to the beams. Once the deck is then laid in position, it becomes a working platform, but also is a crash deck, and so allowing work to carry on unimpeded on the level below. The shear studs are then taken and placed in position through deck welded onto the composite beams. The steel mesh is then laid, concrete poured, and then it's finished.
Comfloor is a high-quality composite decking product, manufactured with tight controls on testing and packaging. It has been proven to provide significant savings in both construction time and overall structural costs in buildings all around the world.
Now again, I'd like to show you certain structural details. The picture on the left, this whole picture, the one on the left side is the perpendicular edge conditions, meaning to say you are going to use the long side of the steel beam, while the one on the right is the parallel edge condition, wherein you will use the other side of the beam, wherein there has no ridges over it. This picture on the left is a double steel decking. Why double? Because in the event you would like to install insulation, floor insulation on the floor, you will first place your primary steel deck, then place your insulation on top of it, then you will place your secondary steel deck. Well, hopefully you've learned something new regarding steel decking and steel framing. Watch out for my next video wherein I will talk about floor finishes using stone and tiles.